So now we want to talk about, now that we've talked about moment of inertia, now that we know about rotational energy, let's go back to our initial question. Right, we wanted to find out what happens with the kinetic energy if we have something that's rolling without slipping, right? And so let's just take a look. Let's say we have two different cases. Let's say in the first case we have a wheel, okay, and it's on the ground, and it's moving to the right with some velocity v. Well, a point on the bottom, if it's, let's say in this case it's slipping. Okay, so it's on a frictionless surface. Well, the bottom is going to be moving to the right with the speed v. A point on the top is going to be moving to the right with the speed v. A point on the side is going to be moving to the right with the speed v. Right? Every point on this, because it's a compound object, is going to be moving to the right at the exact same velocity. Now let's look at something that's rotating. Okay, so if this is rolling without slipping, okay, overall the center of mass is still moving with a speed v. But the point on the bottom, because this is rotating, there's a component, so the overall translational movement is moving to the right, but remember it's rolling on the ground. So if you think about something rolling, think about this point up here, and as it rolls down to the bottom, it's actually stationary on the ground while this is rolling. And the reason is because, remember, it's moving to the right, but it's also spinning around, which means there's a component going to the left with a velocity v. Now, on top, because this is v is going to be the speed that a point on the outside of the wheel is moving. So at the bottom, because v is a vector, the net is actually 0. So at the bottom, this point has no net speed. At the top, the wheel is spinning to the right. It's also moving to the right. So a point on top actually has a speed equal to 2v. And then every other point is going to have some something in between the two, somewhere between 0 and 2v. So what does this mean for the kinetic energy? Well, so for the kinetic energy, we know that the kinetic energy due to translation is 1/2 mv squared. But there's also another term due to rotation, which is 1/2 I omega squared. So now we use both of these put together to calculate the energy of the object. So if we go back to that first example we looked in the first lecture in this series, we said we had a ball with a mass m rolling down an incline theta. We said it was at a height h, and we wanted to find its velocity at the bottom. Well, its initial energy was mgh. It was all potential. At the bottom, there's going to be no more potential energy. So now the energy becomes 1/2 mv squared plus 1/2 I omega squared. Now for a ball, the moment of inertia is equal to 2/5 m times the radius squared. So this term becomes 1/2 times 2/5 m times the radius squared. Remember, omega is just v squared over r, so this becomes velocity squared over r squared. So the radius terms cancel out. So we see that we have 1/2 mv squared, 1 plus 1 over 5. So in other words, 2gh over 6 over 5 is equal to mv squared. So the velocity is the square root of 10 over 6 gh. I think I made a mistake somewhere. Let me see if I can find it. Not sure where, but I think I did make a mistake somewhere in this calculation. But the basic idea, the basic idea though is that we have the velocity is going to be some different velocity than the velocity would have been had it just been sliding down. Because if it was just sliding down, the velocity would have been the square root of 2 gh. So I'm not sure where I made my mistake, but there's a mistake in there somewhere. But this is basically how you would go about solving it. I'm just making some kind of silly math error somewhere because I'm not thinking about something. Oh, because I multiplied by a half over here. So this should be 2/5. There we go. So this is 2/5, which means this is 7 over 5, which means this is 10 over 7. Right. So our new velocity is equal to the square root of 5 over 7 times the velocity if it wasn't rolling, which is what we said it should be from the first lecture in this unit.